morning guys, this is Srinivasana Peruri, math educator. Yes sir, today I am going to explain differential equations. The subtopic is non-homogeneous differential equation. Homogeneous part is completed, now non-homogeneous equation. So if A1, B1, C1, A2, B2, C2 are real numbers and at least one of C1 comma C2 should be non-zero. I repeat, if A1, B1, C1, A2, B2, C2 are real numbers and at least one of at least one of C1 comma C2 should be non-zero. That is, at least one of C1 comma C2 should be not equal to 0. Okay, then dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2 is called non-homogeneous differential equation. Okay, repeat. If a1, b1, c1, a2, b2, c2 are real numbers, and here the main important condition is c1 comma c2 should be at least one of c1 comma c2 should be not equal to 0, or both are not equal to 0, but at least one should be non-zero, right? So then dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. So how to recognize this one is a homogeneous or non-homogeneous? So look at this. Yeah, for example, okay, right. So here independent constants are there, C1, C2. There no doubt it is okay, non-homogeneous. For example, C1 is not there and C2 is not there, right? So this is the equation. This is homogeneous simply. So like this one is C1 and this one is C2. How to solve this type of non-homogeneous differential equation? Okay, actually three types are there. Okay, number one is case 1. So if b1 is equal to, let b1 is equal to minus a2. If b1 is equal to minus a2, one should recognize, okay, right, b1 is equal to minus a2. Okay, right. Then, so look at this. Okay, this is the equation number star. Okay, star implies dy by dx is equal to, yes, a1x. Okay, b1 is equal to minus a2. Okay, y plus c1 by a2x plus b2y plus c2. Since b1 is equal to minus a2. Now, cross multiplication. a2x plus b2y plus c2 into dy is equal to, yes, a1x minus a2y plus c1 into dx. So this implies a2x dy plus b2y dy plus c2 dy is equal to a1x into dx minus a2y into dx plus c1 into dx. Okay guys, now this one is, look at this, these two terms. Okay, so this implies a2x dy plus a2y dx plus b2y dy plus c2 dy minus a1x dx minus c1 dx is equal to 0. Now here a2 common. a2 into x dy plus y dx plus b2y dy plus c2 dy minus a1x into dx minus c1 into dx is equal to 0. So here x dy a2 into a2 into this one is x dy plus y dx is equal to derivative of xy. UV whole dash is equal to U dash into V plus U into V dash. Okay, right. This term x dy plus y dx can be written as like this, derivative of xy. Yeah, dx into y plus x into dy. That's it. Okay, plus b2 y dy plus c2 dy. Okay, minus a1x into dx minus c1 into dx is equal to 0. Then applying integration on both sides. So here, yes, a2 into integration derivative of xy, yes, plus b2 constant integration by dy, okay, plus c2 constant integration dy, minus a1 into integration x dx minus c1 into integration dx is equal to constant, say, k. Constant k. Okay, why? Because this one is a2 is a constant, that's why it is independent of this integration. So this total term integration of this total term is equal to a2 is a constant integration dxy, just like this, is equal to k. Now here a2 into integration of derivative of xy is equal to xy. Why? Because derivative integration means anti-derivative. So this one cancel. So xy plus b2 into, yes, we have the formula integration x power n into dx is equal to x to the power of n plus 1 by n plus 1 plus. This is the formula. So then apply the formula y plus 1 plus 1 by 1 plus 1. Okay, this is completely y function. Okay, plus c2 into y, integration derivative cancel. Okay, minus a1 into, again applying the formula integration x power n into dx is equal to x power n plus 1 by n plus 1. So that is equal to x power 1 plus 1 by 1 plus 1. Okay, right? Minus c1 into x is equal to k. So this implies, yeah, a2 into xy plus b2 into y square by 2 plus c2 into y minus a1 into x square by 2 minus c1 x is equal to k. This is the solution of, okay, this non-homogeneous differential equation when b1 is equal to minus 8. That is very important. Okay, right? So once you check it that b1 is equal to minus 8 or not, simply substitute b1 is equal to minus 8 in the given differential equation and okay, right, cross multiplication. Then we have to consider this one is x dy by dx. That can be written as derivative of xy. Remaining all functions are y function, x function. Applying integration on both sides, we get the required answer. I'll give you one example. Yeah guys, look at the board. Solve x plus y minus 1 into dy by dx is equal to x minus y plus 2. This is the question. Now first we can arrange that equation into the standard equation of the non-homogeneous equation, that is dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. That is, so given differential equation is dy by dx is equal to x, okay, 1 into x plus minus 1 into y plus 2 whole divided by 1 into x plus 1 into y, okay, plus minus 1. This is equal to how much beta? a1x plus b1y plus c1 by, yes, a2x plus b2y plus c2. Okay, yeah, constants are there, so no doubt it is non-homogeneous differential equation, confirming. And once you check it, is it b1 is equal to minus 8 or not? Yes. Now here a1 is equal to how much? 1. And b1 is equal to how much? Minus 1. c1 is equal to 2. And a2 is equal to 1. b2 is equal to 1. c2 is equal to minus 1. So here b1 is equal to minus 1. So minus, yeah, a2 is equal to how much? Okay, that's it. a2 is equal to 1. Relation between, right. Sir, the a1 is also 1, no? So why are writing the b1 is equal to 1? Yes, the condition is if b1 is equal to minus a2, okay, right. If b1 is equal to minus a2, then put b1 is equal to minus 8 in the given equation, then cross multiplication, then we can arrange x dy plus y dx. You have to consider same two conditions only, x dy plus y dx. That is very important. So note out b1 is equal to minus b2. Okay, fine. Then cross multiplication with this one. So this implies, same, right? So given equation, this one is equation number star. Star implies x plus y minus 1 into dy is equal to x minus y plus 2 into dx. That's it. Okay, guys. Now this implies x dy plus y dy minus dy. This is equal to x dx plus y dx plus 2 dx. That's it. So here, we have to concentrate. This one is mixed family. X and y. Mixed means x and y family. So x dy minus x dy like this. This is minus. Sorry, right. So plus y dx. Okay, plus y dy minus dy minus x dx minus 2 dx is equal to 0. Now this part, this is, you have to concentrate x dy plus y dx. That is equal to derivative of xy. That's it. Applying uv rule. Derivative of uv is equal to u dash into v plus u into v dash. That's it. So like this, uv whole dash is equal to u dash into v plus v into v dash. That's it. Okay. Now, so plus y dy minus dy minus x dx minus 2 dx is equal to 0. Then apply integration. Integration derivative of xy plus integration y dy minus of integration dy minus of integration x dx minus 2 into integration dx plus c constant. Okay, guys. So derivative integration cancel. I repeat, integration means anti-derivative, right? So now, xy this one, okay, plus, we just I told you integration x power n into dx is equal to x to the power of n plus 1 by n plus 1 plus c. This is the formula, right? So this one is y power 1 plus 1 by 1 plus 1 minus y, derivative integration cancel, minus x power 1 plus 1 by 1 plus 1, okay, minus 2 into x is equal to c. Right. So this implies xy plus y square by 2 minus y minus x square by 2 minus 2x is equal to c. Okay, right? Of course, this one is constant. Okay, this constant is equal to, say, I suppose that c by 2. Why? Is it necessary to write like this? Why? We can take LCM, 2 cancel. For example, this LCM is equal to 3, then we can write it as c by 3. Or no need that one, enough. Okay, r plus is equal to c, right? So LCM is equal to 2. So 2xy plus y square minus 2y minus x square minus 4x is equal to c by 2. This one is cancelled. That's why the constant can be written as c by 2. Okay, yes. So this implies y square minus x square plus 2xy minus 4x minus 2y is equal to c. This is the final equation. So conclusion is, one non-homogeneous differential, initially you have to recognize, okay, is it non-homogeneous or homogeneous? Non-homogeneous is separately independent constant is there, like this. This one is, no doubt, it is non-homogeneous, number 1. Number 2, check it that one. If b1 is equal to minus a2 or not? Yes, suppose b1 is equal to minus a2, then simply cross multiplication. And we can arrange x dy plus y dx in one term. That is derivative of xy. That's it. Then applying integration, we get the required answer. This is the process. Yeah, yes. Model number 1 completed. Next model number 2. Right? So given differential equation dy by dx is equal to, yes, a1x plus b1y plus c1 by, yes, a2x plus b2y plus c2. Right? Here b1 is equal to minus a2. Then simply cross multiplication. Then we can arrange x dy plus y dx in only one term. Then applying integration, we get the required answer. Okay, simple, very simply. Okay, solution. Right. The model number 2. If yes, a1 b2 minus a2 b1 is not equal to 0. If a1 b2 minus a2 b1 is not equal to 0, yes, then there exist h comma k such that a1h plus b1k plus c1 is equal to 0 and a2h plus b2k plus c2 equal to 0. Okay, right? Where we have x is equal to, right, small x is equal to x plus h, small y is equal to y plus k. Listen carefully. Okay, right? If the given differential equation is of the form, yeah, dy by dx is equal to a1x plus b1y plus c1, a2x plus b2y plus c2, and model number 1 already completed. Now here a1 b2 minus a2 b1 is not equal to 0. Then there exist two real numbers h comma k such that a1h plus b1k plus c1 is equal to 0 and a2h plus b2k plus c2 equal to 0. Solve these two equations, we get the values h comma k. Then small x is equal to x plus h and small y is equal to y plus k. Okay. Then substitute these two values in this equation. This equation becomes homogeneous equation like this. X is equal to, yes, a1 into x plus b1 into y by a2 into x plus b2 into y. Then old process, y is equal to vx, homogeneous equation. But as a senior-most faculty, it is not advisable for the students. Examination point of view, this is very critical, very critical with respect to my point of view. Okay, right? Student point of view, it is very critical, not my point of view, sorry. Right? So here, so this one is very lengthy calculation. But the reason is very lengthy calculation. That's why don't select this type of question in the annual examination board problems. Okay, right? Yes, clear na beta? First one is okay. B1 is equal to minus A2, okay. But don't select this model. And it is okay, important for the EAP set. Simple question is there. Okay, dy by dx is equal to one question given. Right, once you check it. Is it a1 b2 minus a2 b1 equal to 0 or not equal to 0, or b1 is equal to minus a2? b1 is equal to minus a2 means very easy. If a1 b2 minus a2 b1 is not equal to 0, then 4 options given. The substitution method is small x is equal to x plus h and small y is equal to y plus k. Don't forget that one. And what are the values of h comma k? EAP set only. Right. Solve these two equations, we get the values h comma k. Yes. Okay, don't select, I repeat, don't select this type of question in the board. Okay, right. Now model number 3, dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. Right. So now here, yes, let a1 b2 minus a2 b1 is equal to 0. Suppose a1 b2 minus a2 b1 is equal to 0. Right. Then previous one is, number 1 is b1 is equal to minus a2. And the second case is, model number 2 is a1 b2 minus a2 b1 is not equal to 0. Yes, especially just I told now, don't select this type of problem in the board. And the BSc students also don't select this type of problem. Right. Choice is there. Number of questions are there. Okay, right. And BTech students also. Right. So dy by dx is equal to a1x plus b1y plus c1, a2x plus b2y plus c2. Let a1 b2 minus a2 b1 is not equal to 0. Then what the position? Yes. Suppose look at this one question given. So there are 2x plus 2y plus 1 into dy by dx is equal to yes x plus y plus 3. Now this implies dy by dx is equal to x plus y plus 3 by yes 2x plus 2y plus 1. Now this is equal to x plus y plus 3. Okay, yes, of course. This one is okay. 1 into x like this by right. Okay, now 2x plus 2y plus 1. So this one is equal to a1x plus b1y plus c1 by yes a2x plus b2y plus c2. So a1 is equal to 1, b1 is equal to 1, c1 is equal to 3, right? a2 is equal to 2, b2 is equal to 2, c2 is equal to 1. So a1 b2 minus a2 b1. So this is equal to a1, yes, 1 into 2 minus a2 is equal to 2 into 1. This value is equal to 0. a1 b2 minus a2 b1 is equal to 0. Then yes, this is model number 4. How to simplify this type of problem? Right. So common value. So like this equation is dy by dx is equal to x plus y plus 3 by we are taking two common value here x plus y plus 1. Which one is a common value? Numerator and denominator x plus y is a common value. That common value is equal to say some z. Let x plus y is equal to z. X plus y is equal to z. Now, so differentiate with respect to x. So derivative of x with d by dx of x plus y is equal to d by dx of z. Okay. Now d by dx of x is equal to d by dx of x plus d by dx of y is equal to dz by dx. 1 plus dy by dx is equal to dz by dx. So dy by dx is equal to dz by dx minus 1. Okay, right? So this is equation number star. Yes. Now star implies dy by dx is equal to how much? Dz by dx minus 1. Dz by dx minus 1 is equal to yes. This value is equal to how much? Z. Z plus 3 by this value is equal to how much? Z. So 2 into z. Okay, right? Plus 1. Okay, guys. Now dz by dx is equal to 1 plus z plus 3 by 2z plus 1. 2z plus 1. Now this is equal to LCM is equal to yes 2z plus 1, 2z plus 1 plus z plus 3. Now 2z plus z is equal to 3z plus 4 by 2z plus 1. So this one is dz by dx. Dz by dx. Now, so this implies by variable separation method 2z plus 1 by 3z plus 4 into dz is equal to dx. dx. Now, applying integration both sides, integration 2z plus 1 by 3z plus 1 into dz is equal to integration dx plus c. Now, how to simplify this type of integration? Okay, right. So look at this. Okay, now 2z plus 1 by 3z plus 1. 3z plus 1 is equal to 2z plus 1 by 3z plus 1 into 1. So this is equal to split into partial fractions. Okay, a by 3z plus 1, okay, plus b by 1. So this implies 2z plus 1 by, yeah, 3z plus 1 is equal, LCM is equal to how much? 3z plus 1. Now this one is equal to a plus, okay, b into, yeah, 3z plus 1. So this one cancel. Now this implies 2z plus 1 is equal to a plus b into, yeah, 3z plus 1. Now comparing the coefficient of, okay, z and constants on both sides. Comparing the constants of coefficient of z and the constant on both sides. Now coefficient of z is equal to how much? 2 is equal to coefficient of z is equal to how much? 3b. Okay, like this. This one is 3. Okay, so that implies, yeah, b is equal to how much? 2 by 3. Now what about the constant? 1. Left side is equal to 1. Right side is equal to a plus b into 1. Okay. Okay, guys. Right? Or like this. A plus, okay, right? 3b z plus b. Now this is constant. This one is z. Understood? Right. So here a is equal to, yes, 1 minus 3. This is equal to 1 minus 2 by 3. Is equal to 3 minus 2, 1 by 3. So a is equal to 1 by 3. A ready, B ready. Okay, guys. Right. Now, yeah. So this one is this is the equation number 1. So 1 implies, yeah, 2z plus 1 by 3z plus 1 is equal to, yeah, a is equal to how much? 1 by 3. 1 by 3 by 3z plus 1. b is equal to how much? 2 by 3. Then this one is, okay, right, star equation. Yeah, star implies, yeah, integration. This value is equal to 1 by 3 by 3z plus 1 into dz, okay, plus 2 by 3 into dz is equal to integration dx means x. Derivative integration cancel, x plus c. Now this is equal to 1 by 3 into integration 1 by, yeah, 3z plus 1 into dz, okay, plus 2 by 3 integration dz is equal to x plus c. Okay, now how to simplify this type of integration? So derivative of 3z is equal to 3. Okay, 3 is not there. That's why derivative of 3z plus 1 completely, suppose derivative of 3z plus 1 is equal to derivative of 3z is equal to 3. Derivative of constant equal to 0. But 3 is not there in numerator. That's why multiply and divide with 3. So 1 by, yeah, 3 into 3 integration, okay, 3z dz by 3z plus 1 plus 2 by 3 into x, okay, is equal to, into z this one, sorry, is equal to x plus c. Right. Now this one is 1 by 9. Yes, 1 by 9 into, yes. So once again we have the formula integration f dash of x by f of x into dx is equal to log mod f of x plus c. This is the formula. So what is the nature of this type of integration? Derivative of denominator is equal to numerator. Then apply this formula. Log modulus of f of x plus c. So here 1 by 9. 3 3 is 9. Now derivative of 3z plus 1. Derivative of 3z is equal to 3 and derivative of 1 is equal to 0. 3z is there. So this can be written as log of modulus of 3z plus 1. Okay. So if it is any critical, So 3z plus 1 is equal to t, or coffee or Bournvita. We get the answer. Right? It is very convenient. Right? 1 by 9 into log of modulus of 3z plus 1 plus 2 by 3 into z is equal to x plus c. Right. So this is equal to 1 by 9 into, yes, log of modulus of 3 into eliminating z. Z is equal to how much? Z is equal to x plus y. Okay, right. X plus y plus 1. Okay, plus 2 by 3 into x plus y is equal to x plus c. So this is equal to 1 by 9 into log of modulus of 3x plus 3y plus 1, okay, plus 2 by 3 into, yes, okay, right, x plus 2 by 3 into y minus x is equal to c. So this is equal to 1 by 9 into, yes, log of, okay, 3x plus 3y plus 1, okay, plus like this. This one is expanding completely. Okay, right? 2 by 3. 2 by 3 minus 1 into x plus 2 by 3 into y is equal to c. So 1 by 9 into log of modulus of 3x plus 3y plus 1. Okay, 2 by 3 minus 1. Minus 1 by 3. Minus 1 by 3 into x plus 2 by 3 into y is equal to c. Don't take any risk unnecessarily. Enough this one. Okay, right. This can be written. Some lecturers are okay, now discussing with c. This constant is equal to c by 9. Take LCM 9. 9 cancel. Don't take any risk unnecessarily. Enough this one. 1 by 9 into log of 3x plus 3y plus 1 minus 1 by 3 dx plus 2 by 3 into y is equal to c. But the process, if the given differential equation is of the form, yes, a1x plus b1y plus c1 by a2x plus b2y plus c2, then, okay, right, want to check it that one, is it b1 is equal to minus a2 or a1 b2 minus a2 b1 is not equal to 0. Okay, right, or a1 b2 minus a2 b1 is equal to 0. So, three models are there for non-homogeneous, okay, equation. Now, the conclusion is, so, non-homogeneous differential equation. This one is, yeah, dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. This one is non-homogeneous differential equation. Now the models are, yeah, like this. First one is b1 is equal to minus a2. This one is okay. Very simple. Right. b1 is equal to minus a2 means, yeah, once you check it, initially, is it a homogeneous or non-homogeneous? If it is non-homogeneous, and check it, if b1 is equal to minus a2, then simply cross multiplication and we can arrange x dy in y dy into only one term. Okay, x dy plus y dx. We have to focus on that two terms, x dy plus y dx. That can be written as a derivative of xy. Remaining all y families and x families are different values are there. Applying integration, we get the answer. Okay, simple. Now, what about this one? a1 b2 minus a2 b1 is not equal to 0. Yes, this one is very critical with respect to student point of view, not my point of view. Right. So don't take, okay, this type of problem in the annual examination. Either it is board or IPE or CBSE board or BSc students also, BTech students also. So this one is, yeah, what are the process? A1H plus B1K plus C1 is equal to 0 and A2H plus B2K plus C2 equal to 0. Solve these two, we get the values H comma K. Then x is equal to x plus K and y is equal to y plus K. It is very important in EAP sector. Okay, simple bit is there. Right? What is the substitution method for one differential equation? So simply remember this. X small x is equal to x plus h and small y is equal to y plus k. Now what about third model? A1 B2 minus A2 B1 is equal to 0. Is equal to 0. Okay. So this one is common value is equal to 0 in the numerator and denominator value. Then applying, okay, right, cross multiplication and applying the partial fractions. Actually, no need to apply partial fractions. We can arrange, okay, right, that numerator we can. Yes. So if A1 B2 minus A2 B1 equal to 0, then common value is equal to Z. Okay, right? Then replacing the given equation by using the common value is equal to Z, and applying the partial fractions, we get the answer. Right? Okay. Thank you, guys.